Hello, Algebra 2. This is the second day of 724. So this is more practice with dividing radical expressions. And so we'll just jump right into the classwork. The rules are the same as today, and we're just going to get more practice from the same thing that we covered last class. So I'm looking at your classwork, and I'll start off with number 1. So we've got the square root of 48x to the 5th over root 3x cubed. So this is something that we could combine under one radical, one fraction under one radical, and we could simplify it like that. So the 3 will cancel, and the 48 will turn into, let's see if I get a different color here. The 3 cancels, the 48 turns into 16. The x cubed cancels, and then the x to the 5th would turn into x squared. So after we cancel all that, what we have left is 16x squared. So now those are both perfect squares. The square root rather of 16 is 4, and then the square root of x squared is just x. So our answer there is 4x. For number 2, we've got the square root of 24a to the 5th b cubed all over the square root of 12ab. So for this, we'll put this all under one radical. So one fraction under one radical, and then we'll go ahead and simplify it. Okay, so my 12 disappears, 24 turns into a 2. This a would disappear, and this a to the 5th, well, that would turn into an a to the 4th. This b disappears, and that b cubed would turn into a b squared. So what I have left, let's see, well, my whole denominator has disappeared, so then I just have 2a to the 4th b squared. Okay, now we can't take the square root of 2, that'll have to stay inside our radical, but a to the 4th and b squared, both of those exponents are divisible by 2, so we can take the square root of those. So that'll give us a squared b, and then root 2, and we're all done. We'll skip number 3 because that's similar to the ones that we just did, and we'll take a look at number 4. So for number 4, we have 1 over root 3, so we want to get rid of this root 3 in the denominator, so we're going to multiply by root 3 over root 3, and so up top we'll have just root 3, and then down below, when you do this multiplication, the square root cancels, it disappears, so then you have just 3, and you're all done. We'll skip 5 because that's the same kind of thing as number 4, and then going on to number 6, we have 1 over root 6x. Okay, so now we've got a variable inside our radical, but same thing, we'll multiply by root 6x over root 6x. So up top, we'll have just a root 6x, and then down below my square root will cancel, and so I have a 6x. And then with that, we can't do anything more with that, so that's our answer, and we're all done. We've got root 6x over 6x. Now number 10 is a little different. For number 10, we have the square root of 5 over x, okay? So we can't simplify that fraction any further. So this is an example. We haven't seen one like this yet. This is an example where we would break that up into 2 separate radicals. So let's rewrite this as root 5 over root x. And then what we're going to do here, so now the problem is the root x in the denominator, and so we can get rid of that by multiplying by root x over root x. So up top, we'll have root 5x, and then down below, well, root x times root x is just going to be x. And we can't cancel anything further, and that's our answer. Number 11 is going to work in a similar way. So we'll take a look at that one. Good practice for that type of problem. So for number 11, we have the square root of a over 2. Okay, so again, this fraction of a over 2, we can't simplify that any further. So we'll separate our fraction, and we'll have root a over root 2. So 2 separate radicals. Okay, so the problem is the denominator, the square root there. So we want to get rid of that. So we'll multiply by root 2 over root 2. So up top, well, those radicals, all we can do is combine them under 1 and can't do anything further to simplify it. But then down below, the root 2's cancel, and we have just 2, and that's as nice as we can make it, and we're all done. Now for number 12, that's something different. We haven't seen anything like that in any of the examples we've done yet. We've got a cube root. Now how you get rid of a cube root, if you want to get rid of a cube root, you have to multiply 3 of them in total. So we have 1 already, so that means we need 2 more, right? So I'm going to need cube root of 3, cube root of 3. So I have 3 cube roots, 1, 2, 3, right? So I started with 1, I need a total of 3 to get it to cancel, so I needed 2 more. So that's why I have 2 of them here. And so we've got to do the same thing in our numerator. Remember, you always do the same thing in your numerator and denominator. Alright, so now down below, if we multiply all of these out, well, that's just going to give us 3. The cube roots cancel, and so we have just 3, whatever was inside those roots. And then up top, we'll have a 2 on the outside. We can have, because these are both cube roots, we could turn it into 1 cube root, and we could multiply those. So 3 times 3 is 9. And you can't take anything out of, you can't do anything with the cube root of 9. So this answer, this is as nice as we can go, and we're all done. So let's go on to number 13. So 13 is another cube root problem. We have 3 over the cube root of 9. So we're going to multiply by the cube root of 9 times the cube root of 9, right? So we want to get that cube root to cancel. So we need 2 more of them to make 3 to get it to cancel in the denominator. So 3 cube roots of 9, well, that disappears and we have just 9. So then up top, we'll have this 3 on the outside, and then these 2 cube roots we can multiply, and I'm going to have 9 times 9, which is the same thing as 81. Now we can do some simplifying here. Let's look at this 81. So we want to think of the largest perfect cube inside of 81, and that's going to be 27. So we could rewrite this as 27 times 3, and this is all over 9. So the cube root of 27 is 3, so we can pull that outside, right? So I already have my 3 on the outside, and then the cube root of 27 we said is 3, so we'll have another 3 out there. And then this second 3 that's on the inside, well, we can't do anything with that, so we'll leave that on the inside, and then we have our 9 down below. Okay, so we can cancel some things. Well, 3 times 3 is 9, and we already have a 9 in the denominator, so all of that just disappears, and then my answer is just the cube root of 3, and we're all done. Okay, so let's go on to 14. So for number 14, we have root 20 x to the 5th y over root 40 x squared y squared. So this is an example of a problem where we could make this one fraction under one radical and go ahead and simplify it first. And this is going to be different than the ones we've done previously, because we're not going to be able to get rid of our denominator completely. Now, if we cancel between the 20 and the 40, the 20 disappears, the 40 becomes a 2. If we cancel between the x to the 5th and the x squared disappears, and the x to the 5th becomes an x cubed. And if we cancel between the y and the y squared, the y disappears, and the y squared, that just becomes a y to the 1. So if we multiply all of that out, what we have left, we're still going to have our denominator. We'll have an x cubed over 2y. Okay? So now at this point, what we can do, well, we've got to simplify some things. We can't leave a fraction under the radical like this. Let's rewrite this with separate radicals up top and down below. Okay, so the problem here is the root 2y in our denominator. So to get rid of that, we can multiply by root 2y. So I'll kick this down here. So I have root x cubed over root 2y, and we want to get rid of that root 2y, so we're going to multiply by root 2y in the top and the bottom. So up top, that is just going to turn into one radical, and so that'll be root 2x cubed y, and then down below, well, root 2y times root 2y, those roots disappear, and we have just 2y. We can simplify the square root of x cubed, so remember, if you take that exponent of 3 and divide it by your root of 2, you get 1 remainder 1. So that means we'll have 1x on the outside and 1x left over on the inside. Our denominator is still 2y, and that's the most we can do with this problem, and we're all done. Alright, let's go on to 15. So for number 15, I have the square root of 18ab cubed all over the square root of 48a to the 5th b. Okay, so this is one of those things. Let's put this as one fraction under one radical. Okay, so if we cancel between our 18 and our 48, well, both of those are divisible by 6. So 18 divided by 6 is 3, 48 divided by 6 is 8. Our a up top will disappear. The a to the 5th down below is going to turn into a to the 4th. Let's see, if we cancel between our b's, our b down below disappears, and the b cubed up top is going to turn into b squared. So what we're going to have left is a 3b squared over an 8a to the 4th. Okay, so we'll put this under two separate radicals. Right? And so the problem is the radical in the denominator, so we'll multiply by that to try and get it to disappear. So I have root 3b squared up top, and then root 8a to the 4th down below. So then I'll multiply by root 8a to the 4th up top and down below. Okay? So up top, that'll give me, let's see, the square root of, 3 times 8 is going to be 24, and then I'll have an a to the 4th b squared, and down below, I'll just have an 8 a to the 4th, okay? So we can simplify this root 24. Well, 24 is the same thing as 4 times 6, and we still have our a to the 4th b squared, and this is all over 8a to the 4th. So if we kick this down here, well, the square root of 4 is 2. We can pull that out. We can't do anything with the square root of 6. We'll have to leave that on the inside. The square root of a to the 4th is going to be a squared, and we can pull that out. And then the square root of b squared is b, and we can pull that out. And then down below, we have 8a to the 4th. Okay, so we can do a little more canceling. Well, this 2 will disappear, and this 8 will disappear and become a 4. And then this a squared will disappear, and this a to the 4th becomes a squared. So our answer is going to be b root 6 all over 4a squared. Okay? And that's it. Let's go on to number 19. So 19 is different than some of the other ones that we've done so far today, because in our denominator we have something that's being added or subtracted. So we've got 2 root x minus 4, or 2 over root x minus 4. So we want to get rid of that. So what we're going to do is we're going to multiply by the complex conjugate. And the conjugate is going to be the exact same thing as what we have in the denominator, but it's just going to have an opposite sign. So we'll have a plus sign. So we have root x plus 4. And again, we multiply by the same thing in the numerator and the denominator. So up top, well, this is an easy one because we can just take this 2 and distribute that across root x plus 4. So that'll give us 2 root x plus 8. Right, so I was able to just distribute that 2 across, and then down below, the shortcut that we can use whenever we multiply conjugates is first squared minus last squared. So what I mean by that is we can do root x, the whole thing squared, minus 4 squared. And so root x squared is just x, and then 4 squared is 16. So this is going to turn into x minus 16. And that's as nice as you can make your answer. And you're all done. Let's take a look at 20, which will have the same process. We have negative 5 over root x minus 5, so we'll multiply by our conjugate of root x plus 5 over root x plus 5. Okay, so we'll be able to take the negative 5 up top and just distribute that across. So that'll give us a negative 5 root x minus 25, and then down below we can do the same thing. We'll do first squared minus last squared again. So I'll do root x, the whole thing squared, minus 5 squared, and that's going to give me x minus 25. So that's my new denominator. That's as nice as you can make it, and that's our answer for number 20. Alright, so for 21, I'm going to have root 5 minus root 2 all over root 5 plus root 2. So the problem is the root 5 plus root 2 in our denominator. So we'll multiply by the conjugate of that, which is going to be the exact same thing, but the opposite sign. So that means we'll have root 5 minus root 2. Okay, so to deal with multiplying across our numerators, we're going to have to FOIL. Okay, and so if I multiply my first, well, a root 5 times a root 5, that's going to make the square root cancel, and that'll be just 5. If I do my outers, a root 5 times a negative root 2, that'll give me a negative root 10. My inners, negative root 2 times root 5, will be another negative root 10. And then my last will double negative, so that'll be a positive. And then root 2 times root 2 turns into root 4, which is just 2. Right? And then we can use our shortcut for multiplying our denominators. So that'll be first squared minus last squared. So that's going to be root 5 squared minus root 2 squared, which is just going to be 5 minus 2, which is 3. Okay? So we can simplify some things in this. So 5 plus 2 up top is going to give me 7. And then negative root 10 minus root 10, well, that'll be minus 2 root 10. And then this is all over 3. And that is as nice as we can go for that problem. Alright, so going on to 22. So for 22, we have 3 root 32 minus root 2 all over root 2. So the problem is the root 2 in the denominator. So we can go ahead and multiply by root 2 up top and down below. And so what we'll do with that is we'll distribute that across everything up top. So we'll have 3 times the square root. Well, if I do a root 2 times a root 32, I can multiply the 2 and the 32 and put them under one square root. So 2 times 32 is 64. And then I can do the same thing, root 2 times root 2, that's going to turn into root 4, and I'll simplify that in a second. And then down below, root 2 times root 2, well, that's just a 2, okay? So now our next step, well, the square root of 64 is 8, so we can pull that out. So that's going to turn into 3 times 8 right there. And then the square root of 4 is 2, so we've got that going for us, right? And then we just throw the 2 down below. Now, one more step, okay? This 3 times this 8, those are being multiplied. So that's going to turn into 24 minus 2. This is all over 2. So 24 minus 2 is 11. Or, I'm sorry, I'm jumping ahead. 24 minus 2 is 22. We're divided by 2. If we simplify that, we get 11. So your answer is 11. Alright, let's go on to 23, which could have a similar process. So we have 5 times root 125 plus 3 root 80 all over root 5, right? So the problem is the root 5 in the denominator. So we'll multiply by root 5 over root 5, okay? So 125 times 5, that's going to be 625, and we can throw that under one radical. And then we have plus 3, so now I'm going to do 80 times 5, which is 400, and that goes under one radical. And then root 5 times root 5, well, the roots will cancel, and that'll be just 5, okay? So now we can simplify this. Well, the square root of 625 is going to be 25, so we can pull that out. And when we get to it, that'll be multiplied by that 5, so that's why I have 5 times 25 here. And then I have a plus 3 times, and then the square root of 400 is 20, so I pull that out, and this is all over 5, okay? So if we take it down here, so 5 times 25 is 125, 3 times 20 is 60, and this is all over 5. So this is going to turn into 185 over 5, which if we go ahead and simplify that, let's see, that'll be 37. Yeah, 5 goes into 18 3 times. Yep, 37. So that's 23. Alright, so last problem, 24. So for number 24, we have the square root of x cubed plus root x, and this is all over root x. Okay, so we're going to multiply by root x over root x, because we want to get rid of that root x in the denominator. Okay, so let's see. If we take this root x and we distribute it across what we have up top, well, x cubed times x, that turns into x to the 4th, and x times x, that's an x squared. And then down here, well, root x times root x, well, that'll be a root x squared, that'll cancel, that'll be just x. So if we simplify what we have up top, square root of x to the 4th is x squared, and then the square root of this x squared is x, and we still have our x down below. Now we can cancel. So what we can do up top, we can factor out a GCF of x. So if I kick this down here, alright, so my x squared plus x, there's a GCF inside of that, that's x. And if I factor that out, that leaves me with x plus 1. And this is still all over this x here. So I can cancel these x's, and your answer is just x plus 1. So that's the end of the classwork examples that I want to do. So hopefully you have a deeper understanding of this topic, and this was good practice for you. And then you can go ahead and do the homework for today.